and gentlemen. All right, welcome. Today we are going to be talking about how to graph rational functions. Okay, before you think that that sounds like way too fancy and you can't quite handle that terminology, just focus on the idea of a ratio, something compared to something else. The things we are going to be comparing are polynomials, okay? Basically what we're doing is we're making a fraction where we've got some polynomial divided by a different polynomial, and we're going to see what happens, okay? So what we're going to begin with is the idea of an inverse variation of a function, and that is a. So when we have a as a constant, as our numerator, and then we're going to divide it by something that varies. Okay, so whenever we get started with a new shape, it's always super helpful, in my opinion, to make a table, okay? You can't break the table, but you do need to keep making, different choices so that you can get a sense of what the graph looks like, all right? You don't want to stop with just 1 or 2 points. Okay, the fact that that isn't straight is really starting to get to me. Okay, there we go. So x and y. All right. Easiest numbers, generally speaking, to plug into a basic function, which, by the way, this guy that we're going to graph first is the parent. Okay, this is what all other rational functions, their look is based off of. Okay, so let's start with -1 and 1 and see what happens. Okay, if I substitute in -1, I get 1 divided by -1. And by the way, remember, we're changing the denominator here. That is what's varying. Okay, so I get -1. And if I divide by 1, I get 1. Not like crazy exciting, but hey, they're points. I wonder how they're going to be connected. All right, let's try -2 and 2. All right, that's going to give me 1 over -2. So that's a half. Ooh, little guy. And then like -1/2 and +1/2. All right. Very interesting. All right, what if I put in a half and you might be like, whoa. What's that about, Mrs. Fry? And -1/2. All right, there's a method to my madness. Okay, if I do 1 divided by a half, I have to multiply by the reciprocal. Remember, that's the rule. So it's really 1 times 2. So that's actually 2. And if I do the same thing, I'm going to get 1 over -1/2. So that's really 1 times -2. So it's just -2. Okay, so I'm starting to get this little like curve going on here. Like we are hard no on the axis of symmetry, or, the origin. Anyway, I want you to think about this. We're taking 1 and we're dividing it by increasingly bigger values. Well, that's only going to get smaller. Think about your pizza. If you keep dividing the pizza up into smaller and smaller pieces, they're going to get tinier and tinier. But you're never going to have no pizza. So the graph is ultimately going to trend to where it gets really, really close. You know that word approaching? Coming up again. So we are approaching 0. That's because we have a horizontal asymptote at y equals 0. All right, now what about, there's a number that I didn't substitute in yet that we didn't test. I didn't test 0. 1 divided by 0. Can't do that. That's undefined. Okay, how do we graph an undefined thing? We graph it as an asymptote also, but this guy is vertical. So we also have a vertical asymptote at x equals 0. Okay, so that means this graph approaches both vertically and horizontally. Okay, so how do we move this graph? Well, suppose you have a number like this 5 right here. What that's going to do is that's going to shift the whole graph up 5. Okay, so again, if I go to make my table, let's just talk about a couple of numbers. The -1 and the 1. We would take -1, we'd add 5. We'd take 1, we'd add 5. Okay, so we're at -1, 4. And we are at 1, 6. Notice we skipped 5. Why did we skip 5? Well, that's because what else did we shift up 5 units? The horizontal asymptote, which I'm going to abbreviate as HA, went from being at y equals 0. We're also going to add 5 to that, guys, because we add 5 to everything in our y values when we're shifting up. So the horizontal asymptote also at 5. And then what would happen if I substitute in 0? Ooh, still 1 over 0. Still undefined. Doesn't matter that we're adding 5, which means our vertical asymptote didn't change. So that is still vertical asymptote, still at x equals 0. Okay, so that means we have one branch. That's what we call these pieces or chunks of the graph. We have one branch in the upper right-hand corner, and we have another one in the lower left-hand corner. Okay, I'm going to talk about specifically one feature of this graph, and that is the range. Okay, so the range graph goes on and on. There's graph existing, and wah, hits a wall. So that would be from negative infinity until 5. And then these are all parentheses because we can't be equal to these values. But then as soon as we skip over 5, the graph continues forever up. So that's 5 until infinity. So that's the range of this function. Really, everything is possible except 5. Okay. Now let's talk about this denominator. Okay, this can be a little tricky for people, but let's talk about this. This is inside the function. So that means it's a horizontal shift, which means we're going to move. So it ultimately moves the vertical asymptote, the VA, the vertical asymptote. And if you're like, I don't get it. How can you move something that's vertical horizontally? Well, here, I'll show you. The parent function, vertical asymptote, is at 0. If I'm going to shift it, here, wait, let me write down one other thing for you guys. Sorry. This is going to shift you left 5. Okay? Watch this. This thing is vertical, but moving it up or down, that's not going to do anything. It's just going to be infinite forever. But, however, when the graph shifts left or right, that affects this asymptote. So this graph is going to shift left 5. Now, if you don't believe me, let's think about it this way. The parent function would normally be like -1, 0, and 1. Those are the places that we would graph. And 0 would be where an asymptote is. Well, if we subtract 5 from all of those things, now, x, y, we're at -6, -5, and -4. And -5 is where the asymptote is, because that's where it was before. It was at 0. And then this is -1, and this is 1. So now -1 and 1, x, y. All right, hopefully that makes sense. And then because we didn't shift vertically, our horizontal asymptote is still at 0. And here are the branches. Oh, sorry guys, that was not very clean. One branch, second branch. Okay, and in this problem, I'm going to talk about the domain a little bit more. So the domain of this function would be, so if I start over here, graph is happening, graph, hit a wall. Okay, so negative infinity until -5. And then as soon as I skip over -5, I pick back up, I could go on forever and ever and ever. So that's a union with -5 to infinity. So to kind of summarize everything, transformational form, y equals the a value over x minus h plus k. Vertical asymptote happens at x equals h. Remember, it's the opposite of whatever you're looking at. And the horizontal asymptote happens at y equals k. And that's just the same. Whatever you see is what it is. The domain is ultimately affected by that vertical asymptote. It's going to be negative infinity comma something, union with something comma infinity. And then the range is affected by the horizontal asymptote, negative infinity until something, union with something to infinity. By the way, that is a sketchy looking parenthesis, guys. Whew, there we go. There will only be one horizontal asymptote. Okay, that's it. One of them. No more, no less. But there will be one. There will be at least one vertical asymptote. There could be more. We probably aren't going to get into too many situations where there's more than one, but it can happen. I just wanted you to know that it's possible. Okay, Now, if you want to pause here, this is just a moment where you can kind of read a little bit more details about the simple look of a rational function. I already graphed this function, but if you want to kind of get a little, summary of that, here we go. And then here's some information about graphing translation. So I just showed you 2 examples. The most important thing is this first step, drawing those asymptotes, okay? And then the second thing I would just say, step 2, I know it says plot points, but like really, just make a table, guys. Just find some points, get a feel for the look of that function, okay? So I'm going to show you an example, and then there's maybe one other thing, but we may have to make a second video for that. So we'll see what we have time for. Okay, so quick example. If you go to graph a rational function, identify where your asymptotes are. So x equals 3, vertical asymptote, positive 5, that's going to be where my vertical or my horizontal is. So 1, 2, 3, 4, 5. Oh yeah, it's just barely going to fit in this grid right here. And then there's going to be a point, since this is a 1, that means there isn't any other dilation, so my graph is going to be like this. 1 branch, second branch. Ta-da! All right, stay tuned. There's probably going to be a little bit more.